Hello, my name is Tom Foottit, and welcome to my talk on towards intent-based service assurance with Cisco CNC and NSO and Accedian Skylight. We'll start a little bit first with who I am. So my name is Tom Foottit. I'm head of product for Accedian, but I'm a software engineer at heart and by training, and I'm here with my software engineer hat on today. And I'm going to talk a little bit about Accedian and Skylight and Cisco NSO and CNC. Accedian is a Cisco partner since last year, since 2021, but we've been around for a while. We've been around since 2004, actually, and we've been doing performance visibility the whole time. And you'll hear me use the word Skylight a whole bunch during the presentation. Skylight is just the Accedian product for performance visibility. So when I say Skylight, it's just our product. All right, so let's talk a little bit about what performance visibility is to start with. What do we mean when we say performance visibility? And really the thesis of Accedian is pretty simple. Packets don't lie. So if you look at how a packet traverses a network, you can learn a lot about the network and applications and end user behavior on that network. And you can look at packets that you generate, or you can look at real user traffic or some combination of both. But essentially, if you look at the packets, you will understand how the network is behaving if you have a packet traverse the network and watch its behavior. And essentially what we do is we generate streams of those packets, and then we use data from those streams to build a statistical model of how the network and end users and applications are behaving. And essentially what we then try and do is bring all the statistical data into one place, maybe combine it with some other sources of performance data. And by doing all of that, you can really learn a lot about what's happened in your network, what's happening in your network right now, and what might happen in your network in the future. And so that's really what Skylight's all about. It's what Accedian's all about. It's what we feel end-to-end visibility is all about. What's end-to-end? So that's an important distinction to make as well. End-to-end isn't necessarily just from one router to another router. In many, or even in most situations, user experience extends beyond, a layer 3 VPN connection, for example, between two routers out into cloud or data center or wireless networks and so on and so forth. So really how we view it is understanding end user experience might involve, a layer 3 VPN connection between two routers, but it might also involve putting packets in other places as well beyond, a core mesh of routers that, might involve, workloads running in data centers or public cloud providers or wireless networks. And so the idea is you want to be able to put packets across that entire spectrum, test packets across that entire spectrum, and to be able to watch the behavior and really understand the full end user experience, not necessarily looking at the core network, although that is obviously a use case as well. And really what we're trying to do when we think about performance visibility is break out a little bit of the network management mindset. There's obviously nothing wrong with network management. It's an important function in every network. It's what I've done with a lot of my career, actually. But at the end of the day, user experience is more than just the status of the equipment in the network. I think most of us have experienced that, debugging feeling where all the lights are green, but somehow something else is wrong, right? Or users are complaining or so on. And so the idea is that you don't want to start, or at least our idea is you don't want to start with the components of the network to understand how the users are experiencing it. You want to start by looking at the end-to-end visibility using packets, and then layer in information about the components of the network to help get a root cause. But essentially, what it means is if all the lights are green, but people are still having issues, you want to be looking at the packets, right? And sometimes the converse is true as well. If there may be routers with red lights on them, but if the user's experience isn't a problem, then, well, you may want to look into it, but it may not be as urgent as you think it is, right? In other words, understanding end-to-end user experience using packets is a great way of understanding how your users are actually experiencing the network, and is a great first line for basically looking at network experience and performance assurance. So in other words, the user experience is more than the sum of the devices in the network. Start with the user. That's the thesis. Okay, So let's talk a little bit about why we would want to automate this kind of visibility, right? What was sort of the point of the presentation, right? Why automate? Why kind of have this visibility automated in your network? And so, not to beat a dead horse here, but again, remember, we want continuous visibility, right? So this is not about troubleshooting, or it's not about one-time tests. It's about building a continuous statistical model of the network performance, right? So in other words, we're running test packets all the time. We're running them, many times a second, 24/7, 365 on every connection in the network that we care about, right? To build that statistical model. And we're doing that continuous visibility. So if you want to do that, if you believe in the thesis here, that's the best way to get visibility of how your network's performing. The other important factor is, of course, networks aren't static, right? And the whole point that we're here with the developer days is talking about being able to automate and program networks, right? So the networks aren't static. If you want continuous visibility, you need to be able to put it in place automatically, right? In other words, when you deploy services, when you deploy components of the network, you want to deploy the service assurance, this continuous visibility at the same time, right? And what that comes down to is that intent-based networks require intent-based assurance, right? In other words, in order to be able to ensure the network matches intent, you need to be able to automate that feedback loop, right? Or if we look at the next slide, that diagram, right? So this diagram on the right, the Cisco diagram, you've probably seen it before. Intent-based networking is not a new concept. But what we're talking about is the green part on the left, right? The verification, insights, and corrective action. And in our opinion, sometimes that gets a little bit neglected when we looked at intent-based networking. There's a lot of talk about, capturing business intent and programming the network to match that business intent. But then what happens when the network's not behaving? What happens with that green part of the feedback loop on this slide that says, hey, the network's not delivering to intent, all right? So the idea is that, for intent-based networking, you need that feedback loop to be set up automatically when the service is set up, right? So that when you need the information, it's there. The testing's not an afterthought. It's built into how the network is deployed. And we call this intent-based assurance. In other words, tell Skylight the service you want to monitor, and we'll monitor it, and we'll let you know when something goes wrong. We'll let you know when there's an issue. There has been an issue, there is an issue, or there is a potential issue, right? So again, you can just tell us what the intent is. Hey, I want to go from A to Z, and let me know when there's a problem. And the intention behind this really is that to make it easy to deploy, right? So when you want to move beyond just automation, this is a way to better automate how you deploy services on the network. And so you might have, for example, a cloud service and a private 5G network with a device at the other end of it, and you're trying to ensure the service in between. So users on that private 5G network are accessing services in AWS. So your end-to-end is between those 2 points. So you basically want to say, hey, I want layer 3 visibility between here and here. Let me know when there's a problem. That's really the goal. And this moves you beyond just simply automation into leveraging intelligence when you're monitoring the performance of the network, right? So in other words, let Skylight take care of that for you and let you know when there's a problem. So we'll deploy the testing, the continuously send the test packets, and then notify you when new issues or potential issues with the service. Okay, so that's sort of what we're talking about and why we're talking about it. Now let's dig a little bit into how we do it. So first of all, I'll talk a little bit about Skylight. I don't want to talk a lot about it, but obviously it's the part of the equation that we're going to be working with. So I'm going to use some terms and I'd like you to be familiar with them when we talk about a demo and so on. So first of all, Skylight really consists of two major pieces. The first of which is what we call sensors, or in Cisco parlance might be probes. And then the other part is the Skylight platform itself, which manages those probes, collects the data, makes them available, makes the APIs, and so on and so forth, deals with the fan out of all the probes in the network and deals with all the automation. So essentially, we'll start at the bottom layer of this picture here with the sensors or probes. And we make we've been making these things for a long time. We started with hardware actually, but we've been doing software-based ones for a decade or more. And as a result, we've got a variety of different kinds of form factors for those probes. So it might be as simple as a Docker container, a VM with hardware assist, a smart SFP, or a module with doing performance monitoring in an FPGA in hardware. Right. So and what you're going to choose, which one you're going to choose depends on what kind of tests you want, right? So am I looking for layer 2, layer 3, layer 4, layer 7? Mostly standards-based tests that we do, although we do have some proprietary ones as well. And where you're going to deploy it, right? So say one end of your test is in AWS, you're going to want a container you're going to deploy, and the other end of your test is on a router that can't run a container on it, so you're going to plug an SFP into it, or it might be an iOS X router that can, right? So we have our sensors or probes packaged as RPM packages that you can install on XR. So you can pick the ends of the tests that you want to do, or the different sensors you want to deploy in the network based on the requirements for your use case, what you want to test, what level of accuracy you need, and what the endpoints are. Can I deploy? Is there some place to deploy a Docker container there, or do I need hardware for timestamping accuracy, and so on? So these really help define your choice of probes in the Skylight system. But at the end of the day, you're going to be putting these pieces of software or potentially hardware into the network to sort of demark the ends of your testing, if you will. So you're going to start from one end and go to another end and back again. And so that's the probe layer, right? So my examples in my demos today will be using the Docker containers, but really it could be any of them. The rest of Skylight really is about software to manage those probes, collect that data, and do something intelligent with it, right? So we've got APIs to automate provisioning of intent-based assurance. We've got APIs to send stream data and events off of the platform. We have a analytics machine learning streaming platform that takes all that data from our probes, can take data from other data sources as well, which we'll talk about in a second, correlate those things, find anomalies in the data, and and be able to push again those events and those data back up northbound, and also provide you with a user interface. So if you want to look at that data, do troubleshooting, internal use, if you will, around troubleshooting or understanding the network, and also external use, providing end customers potentially with their own view into how the network's behaving. So if we go back to that, my private 5G example, perhaps you're someone providing private 5G networks and you want your end customers to have a portal to say, hey, here's how well my network's behaving, or here's how well it's performing. You can do that with Skylight as well. And so the user interface is something that allows you to be customize and build, the views that you want to view, and the drill downs and so on. So really what we do is we talk about going macro to micro. In other words, starting with a really big picture and being able to drill down into root cause, or the other way around, starting with a specific incident, maybe that either Skylight's flagged or maybe another system is flagged, starting with that incident and being able to drill up to understand how impacting it is in the network, and so on and so forth. So the UI is designed to work through those workflows with you as well. So obviously automation is a big key, and every piece of data we have in our user interface is also available via APIs or event buses. We'll talk more about that in a second. But sometimes having a way to look at it is important too for a human. And we'll show this a little bit more when I do demo as well. So, okay, that's the platform, right? We've got the Skylight platform, and we have these probes that are there, and we can have APIs in and out. So how are we hooking that in with Cisco? What have we been doing to make that easier to automate? So essentially, we have REST APIs, but we've also got RESTConf Yang as well. And so we've been building hooks into NSO, specifically in NED, in conjunction with Cisco, so that you can automate the provisioning flow through NSO, right? And so the whole goal there is that you can simplify that provisioning flow by as you're using NSO to automate turn up of a service or turn up of other network infrastructure, you can automate the assurance at the same time. You can use that net, and you can use those RESTConf APIs to hook automating assurance right into your automation workflows out of the box. The next piece is collecting the data that comes back out, right? So if you automate the provisioning, that's great. But then what if there's an issue? What if we're detecting a problem with end user experience or a potential problem? How do we do that? Or if we want to share if you want to share some of the raw data as well, not just the fact that there's an alert because of a problem, but potentially you want to look at some data for some reason as well. How do we share that back out of the system? And so essentially we have a couple different ways. We support RESTConf events. And so you can basically, the same NED that you use to provision can also be used to receive events via RESTConf as well, which allows you to take action in NSO. We also expose a couple of different interfaces, MQTT, Kafka, and so on, but GNMI is the one we've been using with Cisco. So we're basically feeding that also back into Cisco CDG, so you can take a feed of our performance data or a subset of that data into CDG and then share that, for example, with CNC network and service health. And so we've been working together with the Cisco team on making all that happen so that you can automate the provisioning and then you can automate the events and the data coming back out of the system and share it with the wider CNC ecosystem through CDG. The last piece of the puzzle is really about adding more performance data to the equation, right? So as I mentioned earlier, we always say, hey, start with the packets, start with the end user experience, end-to-end flows, put our sensors or probes in the network, let us understand that behavior and use that as the sort of the leading indicator for potential problems in the network. But obviously, sometimes it's useful to be able to correlate the data that we're seeing with other data sources, right? So potentially network devices or other sources of performance data in the network. So what we do is we support what's called OpenMetrics, and it's a CNCF standard for data ingestion, or maybe better said, it's a CNCF standard for sharing time series data. And so we support that standard. It's derived from the original Prometheus de facto standard that's been around in the open source community for many, many years. And it's a great self-describing format. And the great advantage of Prometheus is that because it's been around and it's been so ubiquitous, there are a ton of libraries for it. Telegraph supports it. There's language bindings for every language in existence. It's really easy to use it, and many sources of data have already got a Prometheus feed. Now, we understand that we also live in a world where a lot of those feeds are not from IT systems. They might be from network devices and so on. So we support out of the box Cisco model-driven telemetry, MDT, via GNMI. And we also support good old-fashioned SNMP as well, because there's lots of stuff out there that, the best way to get the data is unfortunately still using SNMP. So that's the best way to retrieve performance data. So we support that as well. And we support OpenMetrics, and anything can provide an OpenMetrics feed, or you can write your own code to provide a Prometheus push metrics endpoint or an OpenMetrics endpoint, and essentially convert anything into a feed into Skylight Analytics. And then the goal there again is that you're correlating that with the data from our probes, and Skylight has a method of doing auto correlation. So you can tag your data with what we call metadata, and then Skylight will use the metadata to do correlation. So for example, how do I know that this end-to-end test I'm doing is going through this specific router? That's metadata. And we'll show that a little bit in just a second as well. Okay, so that's basically the ecosystem then. We've got Skylight, which really consists of the probes or the sensor layer, in our words, and a management layer that does analytics and user interface and everything else. But that management layer has got great APIs, and we can use those APIs to automate the provisioning of service assurance when you deploy a service, to automate collection of data and alerts coming out of the platform, and to lay even more data sources beyond just our probes for other performance data sources into the platform to get that single pane of glass view of how the network's performing and be able to drill down and speed up how you're getting to root cause. So what does that mean for the end result? Really what that means is that NSO with Skylight allows you to automate and really close that loop in intent-based networking with intent-based assurance. And we're integrating Skylight data into CNC network and service health with the next major release with CNC 5. And this will also allow you to share that data with the rest of the CNC platform. And again, we can leverage Skylight as an assurance platform as well by taking our probe or sensor data, laying other data sources in, and getting a single pane of glass view as well. So let's continue next with a demo and see it in action. So here's a demo, and I'll show you a little bit of how Skylight works and how it works in conjunction with CNC and NSO. So first of all, we'll start with our user interface, which is also where we'll end up, right? So this is, I've logged into Skylight already, and I've got a system that's got some data already in it, which is great because I'm not going to go through the process of building it all up from scratch. I want to have some historical data in the system to be able to show, but this is an example of Skylight and what you see when you log in. This dashboard is just showing some layer 3 data. It's pretty straightforward. The whole idea is you can customize the user interface to do whatever you want. So I could delete this dashboard and rebuild it again in probably about 5 minutes. It's fairly straightforward. So let's start from the beginning, right? So as mentioned, if you're deploying a service, you want to be able to deploy, end-to-end testing for it, right? So you need a probe at one end, a probe at the other end, and then you want to deploy a test. So how would you automate setting that up? So we'll start a little bit with that. So first of all, it's very straightforward to be able to deploy the actual probes themselves. So as I mentioned, we'll start with our Docker container-based one, but essentially, we supply Helm charts. You can use Helm and Kubernetes to automate the deployment. You can use a variety of other tools as well. Docker Compose works just fine, and any other real automation process with Docker would work just fine as well. But for example, this being able to deploy an agent is as simple as, if you, assuming again you've already got your cluster set up, right? I have a EKS cluster set up, and so if I use this script, I can basically use that to automate using Helm to deploy an agent, right? And the agent's got an ID and then an IP address to phone home from, and an authorization token, which you can generate using our APIs. This is just a Python script, which will generate a token using our APIs. So an authorization token, an ID, and an IP address of where to phone home to is basically all it needs. And it's up and running by running this Helm install. So it's pretty straightforward. Once you've actually got it running though, and it phones home, you need it to have it phone home to do something, right? So let's go back and look at some RESTConf APIs, right? So the first thing you would want to do is you'd want to be able to create the actual agent itself. In other words, when it phones home, who am I, what am I, right? So you'd use the same ID, the same UUID I just used to create it in the Helm chart. A couple of parameters, to basically tell it what IP address to go through to phone home for. Obviously, it would be not 127.0.0.1 unless you're running on the same host. But basically, the main parameter is where do I phone home to, and so you can basically run this. This is a RESTConf call, so this is one of the things you can automate using RESTConf through the Accedian NED with NSO. Then once the agent or sensor is up, or probe, I guess, the other thing you'd want to do is create a session. So for example, you might create a session again, and there's a variety of parameters here that you could pass through. Again, this is the RESTConf call that can come through NSO. I won't go through all of them, but essentially normally it's just a bit, setting up the packet DSCP markings and other markings, and basically saying, hey, I'm sending it from here to there, right? And so again, you run this call, and now your session is set up and running, right? And so it's set up and running, and when that agent comes up, it will say, oh, this is who I am. Oh, this is the session I'm supposed to run, and it will just go ahead and run it, right? So, and that data will start flowing through. And so if I go back into Chrome again, what I'm going to see is that I'm going to see that data show up in inventory, right? So if I go and look at a specific session, for example, again, I already had these set up and running just so that would be some historical data, and we didn't have to sit here and watch my screen while this all rolled through. But essentially, you would start to see some data here, right? So you can see a bunch of data flowing through. And so once the session's up and running, you're all good, right? And if you specified a alerting policy that went with it, right, which could be manual, you could specify specific thresholds, or you could specify intelligent thresholds allow Skylight to learn about normal behavior and flag what we consider abnormal behavior, right? Some intelligent learning, we could do it that well, and then we would generate alerts. In this case, there's no specific alerts here, but that's the idea, is that we would generate alerts. So that's one session that you might set up. And obviously, if you're setting up a network, there would be many sessions. And then the whole idea is you can bring them all together. So the other thing you'd have to do is you'd have to say, hey, what data do I want to make available? So in this case, if I go to session and data ingestion, right? So if I look at, so I set up an Accedian TWAMP session, what's a layer 3 active test, right? Two-way, so probe to reflector, reflector to probe, and also round trip. So we calculate both round trip and one-way metrics when we calculate that. And there's about 56 different metrics that we calculate in total, right? So again, we're building a statistical model. So you can see here, there's some raw metrics like delay and jitter and so on that we calculate percentiles and standard deviations on. And we also can calculate some derived metrics like congestion and so on and so forth as we do this. So you can see all the different metrics, and you can basically enable the metrics that you want, right? And then once you build that up, then that builds up into all the data that you're collecting, all the data you enable. And then when you go back and look at, something like a dashboard that has a lot of data in it, then, this is the correlation of data across many sessions, right? So rather than looking at one session, like I was looking at just a second ago, I'm looking at all of the data, or all the data that's tagged with a specific tag, for example. And this is rolling up a whole variety of sessions and allows me to see this high level view of my network, right? And so I could be looking at raw data like this, or I could be looking at congestion or other higher level indicators that I might want to show. And again, it's easy to build these custom dashboards in the solution. And the whole idea is that you can, you might be looking at, for example, concerns about packet loss. So the whole idea is you can basically, do a one-click drill down. I'll just blow this up in full screen, and you can sort of see, you can see where potential packet loss issues are occurring. You can look at the topology and see where the topology issues are. In this case, it's everywhere. It's not a great example, but basically allows you to drill down into the data, see correlations, see topology, see raw data, and understand what's happening in the network in a single click. The other important thing that I mentioned earlier that I wanted to show in the demo is about adding data sources. So I'm not going to go through the whole process of adding a data source from scratch, but I will say that if you have a Prometheus or OpenMetrics data feed, it's super straightforward. So again, the great thing about OpenMetrics Prometheus is that it's self-describing. So, and this entire platform, user interface, and all the analytics and streaming analytics and so on we're doing are all data-driven. So all you really have to do is be able to add a configuration file that says, hey, here's a new data source, and then it will just start collecting that data and flow all the way through. And then you would be able to go in to session data ingestion and enable that data. So if you had an OpenMetrics data source, you'd be able to enable it there, select the attributes you want, and the data would flow through. So if I look at, again, I'll go back to Postman here, right? But if I basically create a new scraper, as we would call it, right? Then, again, what we're essentially doing is just passing a Prometheus configuration into it, right? So this is essentially just a YAML, which has been stringified here. And so it basically just, specifies a scrape interval and where it's scraping from, right? So in this case, I have a container running locally on port 8081, and it's going to scrape every 60 seconds data from that endpoint, and then stream it in Skylight Analytics. So that's basically it. You basically set up this configuration, and then you download our polar. So when you go back to Skylight here, if I go down to go back to data ingestion, and you might, when you make that API call, it's going to create an entry here, and basically I can just download that connector configuration. That will be a Docker container, which again you can just spin up, and it will start taking that OpenMetrics data feed, streaming the data in, and within a minute or two, you're going to see data flowing through into the system from an OpenMetrics feed as well. So again, super easy to automate. Programmatically, APIs are there and ready to onboard new data sources easily and simply. Okay, so that's it for our demo. If you'd like to learn more, all of the code and examples that I showed today quickly, I know it was all flashed up on the screen pretty quickly, are available on GitHub if you want to have a look. Our documentation is available online as well. You can see the link there, and our API documentation specifically is at api.accedian.io, and we've got some documentation on building integrations with the platform. If you've got more questions, you'd like to try this out, you can feel free to contact me at tfoottit@accedian.com or cisco.com or on Cisco WebEx. Thank you very much.